Thank you, Scotty, for that great introduction. I just wanted to, before I started, I just wanted to say a couple of words about Scotty. Through my career, I've had the opportunity of working with a lot of intelligent, smart, and strong driving people. But I think it's about 20 years ago when Scotty and I worked together. And even at that time, I knew that this man was going to go places. And I think he's proved me right. The organization he's running or part of at Sage is doing great things in the industry. And his participation and contribution to this conference also is a testimony to his capability, energy, and drive. So, as Scott said, my background and expertise is primarily in the area of process safety management. But by education and training, I'm a chemical engineer. My bachelor's, master's, and PhD are all in chemical engineering. So a lot of the concepts that I'm going to talk about today have a lot to do with even environmental issues. And primarily, I'm going to talk about how they kind of coalesce together sometimes, and sometimes they are in conflict with each other. And what you can do to reduce those conflicts and get comprehensive benefits from each program. So as a short outline of my presentation today, I'm going to be talking about these different subjects, what pollution prevention means and what relationship it has with climate change, some strategies for reducing methane and carbon pollution, and then, as I said, the conflicts between environmental actions and safety issues and how they arise, give you some examples of that. And introduce a concept which I'm sure many of you have heard of called the inherently safer approach. And what I'd like to tell you in there is that inherently safer approach is something that can benefit environmental issues too. In other words, inherently safer is inherently cleaner, and inherently cleaner is inherently safer. And then how do we approach it from a life cycle approach of looking at things, and conclude with a few remarks. So pollution prevention, first, when the term came into being, it established, or Pollution Prevention Act, going back, it established a new national policy for environmental protection, where EPA stated clearly as that the pollution should be prevented or reduced at the source whenever possible. And this deceptively simple statement or definition, it heralded a profound change in how EPA and the industry was expected to meet its obligation. What I'm talking about is that in the past, people in general, industry, government regulators, everyone was concentrated or focusing on end-of-the-pipe solutions. And with the arrival of the pollution prevention concepts, we were no longer talking about that. We were talking about more in terms of reducing the pollution so that in the first place, you didn't have to look at the end-of-the-pipe solution. Or in other words, move upstream in the manufacturing process to be able to prevent the waste from being generated in the first place. Now, what does upstream mean? How far upstream do we go? Well, today I will tell you that we need to go as far upstream as possible. And I'll tell you what upstream means. I'm not referring to the upstream energy industry and downstream energy industry. That's not what I'm talking about. I'm talking about the process where the life of a plant starts, okay? And we'll go into some detail about that. So How do we want to do that? We want to modify production processes. We want to promote the use of non-toxic and less toxic substances, implement conservation techniques, and reuse materials. As a result of all of this, EPA has recently developed 2010-2014 pollution prevention strategy. And this pollution prevention strategy is based on certain tenets. Those are identify and leverage pollution prevention opportunities to help reduce, number one, the emissions of greenhouse gases, reduce the use of hazardous materials, and reduce the use of natural resources while contributing to a greener and more sustainable economy. I think you'll agree with me that there is nothing wrong with this statement, and what could be truer than trying to do these things. But it's easier said than done, and sustainability and climate change are creating new priorities in pollution prevention. We do want sustainability. Almost everyone would agree that we want to leave the planet in at least the same or even better shape for our children, grandchildren, and so on. But the agreement kind of stops there, and trying to figure out how to get it done is where we start disagreeing, regardless of political affiliations or technical issues. Recently, first of all, backing up, greenhouse gases from human activities are the most significant driver of climate change. Now, while I make this statement, I will also say that there is certain disagreement to that. Some people on one extreme will say that greenhouse gases has nothing to do with climate change, or there is no climate change. On the other hand, there are some people on the completely other extreme that will swear by it. Okay, but the point I'm trying to make to you is that regardless of which side of the debate you're on, and whether you fall in the middle or whatever, if there is a relationship of human activity with climate change and ultimately sustainability, then it would be too late for us to wait another 20, 30 years and then find out that, yes, it had a relationship. Because as you will find out, these changes are irreversible. And once we arrive at a point where we start seeing the negative impacts of climate change, that would be too late to say, we made a mistake, let's go back and do something. So I would urge you, no matter which side of the debate you're on, to think of it that it is something to look at right now, regardless of who comes out to be right. Conserving resources, doing the things, these are things that should not have any political side to it or other issues, because the ramifications, the consequences are so enormous that if we are wrong, then we could be in trouble. So we need to do something about that. Currently, the United States is leading efforts to address the threat of climate change. The President has taken a series of steps to reduce carbon pollution and other greenhouse gases through initiatives that drive energy efficiency, promote clean energy, and put in place the first ever carbon pollution standards for power plants and other facilities. Within the Climate Action Plan, there is strategies to reduce methane emissions. And it's a powerful way to take action on climate change, because the methane emissions are a primary source of climate problems. In August 2014, in partnership with the dairy industry, the U.S. Department of Agriculture, EPA, and the Department of Energy released the Biogas Roadmap, outlining voluntary strategies to accelerate adoption of methane digesters and other cost-effective technologies to reduce U.S. dairy sector greenhouse gas emissions by 25% by 2020. Within the Climate Action Plan, we also have the cutting carbon pollution. Carbon dioxide is a primary greenhouse gas emitted through human activities, and roughly 84% of the current carbon dioxide emissions are energy-related, and 65% of all greenhouse gas emissions can be attributed to energy supply and energy use. The most effective way to reduce carbon dioxide emissions is to reduce fossil fuel consumption. Renewable and clean energy sources are alternative to fossil fuels. But that's where some of the conflicts that I talked about start. When you talk about using these greener energy sources and non-fossil sources, renewable sources, you unknowingly move into some other problems too. So for example, in Europe, the biogas industry has grown rapidly. Germany, the number of plants increased from 370 in 1996 to close to 4,000 in 2009. And even though these are quite simple installations, there are records or documented records of a significant number of accidents. And the hazards are the same as you will see in any chemical plant or refinery, but additional hazards are also introduced. For example, in many cases, you will have biogas plants with hydrogen hazards, asphyxiation from poisoning by gases such as carbon dioxide, hydrogen sulfide, and ammonia. And the problem is sometimes these hazards are not known because the experience with these plants is very new. Another kind of conflict that I can talk to you about, so we want to shift from fossil fuels to other cleaner sources, okay? And people talk about wind energy, solar energy, and biofuels, and I already gave you examples of biofuels. But these clean energy sources, for improving the environment by producing little or no pollution or greenhouse gas emissions. But that does not necessarily mean that we are producing safe energy. For example, workers in the green energy may face, in the green energy area may face the problems that are listed here in these three industries, which are similar to problems that we see in normal industry. But additionally, workers may be introduced to some new hazards for which they may not have knowledge or experience. For example, a common one I like to use is cadmium telluride, a known carcinogen for the solar energy industry workers. So if we're going to go into solar energy, we need to be careful in how we deal with that kind of hazard and risk. OSHA has kept up with some of these things by addressing different standards and different regulations which are there. Primarily, process safety management has been a big driver. And so have other agencies like Scott talked about, EPA, Department of Homeland Security, and then the state and local regulatory organizations. But as I said, one of the concepts that is near and dear to my heart is inherently safer, is inherently cleaner. What does that mean? This is a concept that was popularized by Trevor Kletz in the mid-'80s. And what it means is he presented a very simple paper. The title of the paper was, "What You Don't Have Cannot Leak." In other words, if you have a chlorine plant, then the risk from that plant is chlorine can leak and cause lots of fatalities and injuries. But if you didn't have chlorine there, then it wouldn't leak. Similarly, the concept can be translated to the environment side, and you could say what you don't have cannot pollute, okay? But while it's a very profound and simple concept, think about it. If you didn't have chlorine, yes, it wouldn't leak. But if you didn't have chlorine, you couldn't process or clean water either. So The example I like to use here is that a knife is inherently hazardous. So in the kitchen, you could say, we're not going to have any knives anymore. But then think about it. You couldn't cut vegetables, you couldn't cook, you couldn't do a lot of other things. So the property that makes the chemicals hazardous or environmentally nasty are also the property that make it useful to mankind. And so we have to be careful when we apply these concepts of inherently safer and inherently cleaner. Many in Congress, and sometimes I've testified there, I'll just leave it at that, is that they have a very simplistic approach of that. Get rid of chemicals and we don't have a problem. But it doesn't work that way. As I said, the property that makes it dangerous also is the property that makes it useful. Just take the example of the knife. So we got to use the knife, but we got to come up with ways of how it can be used safely. And Trevor Clark's popularized this, as I said. So there are various concepts. For example, substitution. Substitute a dangerous chemical with a less dangerous chemical. Sometimes it can be done, sometimes it cannot be done. Intensification, use less of it. For example, after Bhopal, a costly lesson which resulted in tens of thousands of deaths, we learned that methyl isocyanate, a better way to approach it is to have just-in-time production, things like that. And attenuation, lower pressures, lower temperatures, so you don't have a problem with larger consequences. The other thing we learned is the issue of the concept of the life cycle of a plant. If you think about it, when you walk into a plant and you see 100,000 barrels per day refinery or chemical plant producing tens of thousands of pounds of chemicals, it didn't occur like that. It just didn't come out of the blue like that. How does a plant's life cycle occur? Somewhere, some chemist sitting in the library has a beaker, test tube, and working with 5 or 10 milliliters of different chemicals. Throws them together, and all of a sudden, voila, he's got a new chemical, a new product, runs out, explains it to his boss. Boss says, looks good, let's do a conceptual design. They do a conceptual design. Even then, there's no plant, nothing exists on the ground, but you start thinking about it, and in concept, it looks good. You might do some feasibility analysis and so forth. And then you go into detailed design and so forth. And then you go into construction. And then you go into pre-startup and commissioning and all of that, startup, operation, maintenance, and so forth. What I'm talking about here is that the decisions you make at even the conceptual design phase impact a lot of what happens down the line. And I'm going to take a little bit of time on this slide and skip some of the later slides because this is an important concept, okay? Remember the days when the United States and the Soviet Union were engaged in the arms race? And part of the arms race was building chemical weapons. Yes, we, the United States, built a lot of chemical weapons too, as did Soviet Union. And we would come back and we'd tell the Soviets, we can kill you 100 times. And the Soviets would go back and make some more chemicals and come back and say, we can kill you 300 times. And so that's how the arms race was going on. But later on, census prevailed, and we figured out, you know, these chemicals, VX, nerve gas, sarin gas, mustard gas, are not only dangerous for the people we're going to kill, but it's more dangerous for us because the storage areas where we were storing them, these things started leaking, okay? Now think about it. We agreed that we're going to destroy all the chemical weapons. Where are you going to build a plant to destroy these chemical weapons? There are 10 sites in the United States where they were stored. Now, where are we going to build a plant? Somebody said build it in the ocean. Somebody said, well, build it in the desert somewhere and so forth. But if you build it anywhere, how would you transport them over there? They're leaking anyway, these containers. Which mayor, which governor is going to allow these transportation trucks to go through their state or locality? None. So the solution was to build 10 plants at the site where they were stored for in situ destruction. Tooele, the second site in Utah where the destruction started, pretty soon they found out the state EPA came and shut them down. Why? Because they found out that as part of the destruction process, they were able to destroy the chemicals to 99.999% purity. But they couldn't destroy mercury that was part of the as contamination in the chemical weapons. Where did mercury come from? Way back in 1970 when they were producing the chemical weapons, somebody came up with a brilliant idea. Where do we store them? Well, we have all these old containers lying by. These containers were used to store thermite, which was used for fuse for artillery shells. And the thermite contained mercury. Now, the thing that they didn't think about, somebody said that, well, it is contaminated. We need to clean it up. They said, why clean it up? We're going to store poison in it, right? You use poison to kill people. Has anyone heard of contaminated poison? They decide to use those containers. Now comes time to destroy them. Just think about the life cycle. They were in the conceptual phase at that time, and you are way down in the demolition phase now. Now you got to destroy them. Now you're in a problem in terms of the decision you made way early on, 40, 50 years ago. So my message to you is that, number one, think through each phase of the life cycle of the plant. And as you think through it, there are several things you can do. Number one, make decisions that make it easier to design the plant then, but not only that, it also makes it easier at every phase of the life cycle, including the final phase, which is the demolition phase. We don't, when we are thinking of making profit and building a plant, we don't think of the demolition phase, but we should. And that's what's called the cradle to grave approach. I had some slides where I go into each one of these phases, but for lack of time, I won't go into that. I want to end by saying these a few messages that I wanted to bring to you. Number one, solutions to environmental problems might create new sources of hazards, as I gave you some examples, okay? But if you take a life cycle approach where you go through each phase of the life plan, then you will find out that a lot of the needs and how you need to approach both problems, they kind of coalesce. The other thing is that it's always better to use upstream solutions instead of end-of-the-pipe solutions. And you will find out that they are less costly also. End-of-the-pipe solutions are always more costly. And the impact of decisions, as you saw, made early on in the plant's life cycle may cause a lot of headaches at the end of the plant's life cycle. So using an integrated approach, a comprehensive analysis, which balances inherently safer design issues with cleaner approaches, I think gives you the most bang for the buck. But when you do that, remember, while the inherently safer concept, inherently cleaner concept, is a simple concept, and people might say, why don't you do that? Why don't you use a safer chemical or cleaner chemical? It's not as easy as said. Sometimes there are conflicts, sometimes there's risk accumulation, risk transfer, and you need to think about all of that. I think this conference, the gathering of people you have, and the exchanges of ideas, I think the industry benefits from that, and these kinds of concepts are useful as you take it back to your plants, take it back to your practices. I thank you for your attention. I thank the organizers of the conference, and if there's time, I'd be happy to take a few questions. Thank you.